8.1 Microscopes. There's this little YouTube video on the history of microscopes. I'm going to post it directly below this video on our course website for you to take a look at. There's two types of microscopes that you need to know about for this course. A compound microscope uses light to light up whatever we're looking at and can magnify between 400 and 1,000 times. Okay, so it makes it that much bigger, 400 times bigger or to 1,000 times bigger. The electron microscope is pretty heavy duty. We would not have access to these in school. These use a beam of electrons rather than light to magnify up to 600,000 times. So we can see individual cells. We can even sometimes see the bumps on like gold, like a sheet of gold. You could see bumps on it denoting different atoms of gold. Okay. So there's two types of electron microscopes. There's the transition electron microscope, the TEM. What we can look at is a very thin slice of an object that's been covered and coated and treated with chemicals and then put in a vacuum condition. That means there's no air particles around it because air particles are bigger than electrons. So we have to get rid of the air around it. This must mean then that the specimen is dead. So the specimen is what we're looking at because we've sliced it up, we've coated it in all kinds of chemicals, and we've given it zero air. Okay, so dead things look good under a transmission electron microscope. Living things. So if you've ever seen the picture of the dust mite or other kinds of moving small objects like cells, they've used a scanning electron microscope. This can produce a 3D image of a specimen that is living. So we did not have to slice it up. We did not need to coat it in chemicals. We can look at it as is. The different parts of a microscope that you need to know. There's the eyepiece where we look through. Most microscopes only have one. Some fancy ones have two, like binoculars. We have objective lenses. There's usually three. There is a short one, which is the low power objective lens. The longest one is the high power, so the most magnifying, and then there's the medium power. Sometimes this thing is called the nose, depends on what we're looking at. The arm is the connection between the eyepiece and the base. There is a fine focus knob, usually a small knob. Sometimes it's separated from the coarse knob, so we could see a fine knob and then a coarse knob as well. So two options, whether that's connected or not. We use the coarse focus knob to move the stage, and the stage is where we have put our specimen. Okay, so there's little clips here usually, and this is where we would put our cell or our plant or whatever it is we're looking at. So our coarse focus knob moves this up and down with fairly large changes per rotation, and the fine focus knob moves it very slightly, so small movements and adjustments to bring it into focus. The diaphragm underneath here just controls how much light gets in. Usually it's like this big circle, and then it can allow lots of light, a little bit of light, smaller amount of light, and a little bit of light, depending on what we're looking through. If something is very thick, we need lots of light to be able to go through that object. If it's pretty thin or small, we just need a small amount of light. Below it, of course, is the source of light, the light bulb itself, and then it sits on the base. I just went through all of these, but here's a list of things to look at for parts of the microscope. This is another cool little video. I do believe this is a dust mite. I can't quite remember, but under a scanning electron microscope, and how disgusting it looks. So how to handle a microscope. They cost about $300, even just the ones that generally schools have. So you want to treat them fairly well, because we don't have endless budget to replace them. You can always pick it up with the arm, all right? And so that was like this piece here. And then we hold the base with our other hand, just so that two hands on the microscope. You don't ever want to touch the lenses of the microscope, so the oil and dirt on your fingers can actually scratch the glass and make it really hard to focus. You're going to clean smudges off the glass with a piece of lens paper. It's fancy. It's nothing like paper towel. That will scratch it. Cover it with a dust cover to protect, and then follow the correct steps when focusing. So when focusing, we use the coarse adjustment knob first to make big movements, and we use the fine adjustment knob to make small movements. We always start with the low power lens, and we work our way up to the high power lens. So again, a microscope has two sets of lenses. The lens you look through is called the ocular lens, and the lens near the specimen being examined is called the objective lens. The objective lens is one of four lenses located on that nose piece, and vary in magnifying power. The lowest power is called the low power, and the highest is called the high power. You can actually determine how big or how much magnification you are getting from a microscope by doing a very simple calculation. You multiply the power of the ocular lens by the power of the objective lens. Here we're looking at a snow crystal. This says it's at 93 times magnification, and 1 millimeter looks like this here. This is at 329 times magnification, and 0.1 of a millimeter is here, so 1/10 of a millimeter on our ruler. So again, our total magnification of the object we are looking for is the ocular lens magnification times the objective lens magnification. Let's take a look at an example. Calculate the total magnification of a 10 times ocular and a 4 times objective lens. So total magnification is ocular times objective lens magnification. So 10 times magnification times 4 times magnification gives us 40 times. So this means the magnifying power of the lens combined with the objective lens is 40 times. If an object is magnified 40 times, the image you see is 40 times larger than the object would appear if viewed with the unaided eye. So here we can see different cells at different magnifications. Sorry, this is so blurry as an image, but at 40 times we can see the different distinctions between cells. At 600 times, we can see like a lot more about each cell. 1200 times, we've just gotten twice as big, and twice as big again. So we can see the biggest difference, obviously, from these first two, and then we're just fine-tuning from there. We get different magnifications by changing the objective lens. The eyepiece magnification doesn't change each time. It's what objective lens we are using of those three, high, medium, and low power, that give us different magnification. So here we have a bunch of different things. We can see some cells here. All right. And we can see different parts and different types of cells and particles. I do believe this is a mosquito. Its eye looks like netting under an electron microscope. So this would be from a compound microscope where we've stained it. Same thing over here. These two, because they are three-dimensional images, must have come from a scanning electron microscope. So calculate the total magnification of the following microscopes. Just some extra practice here. Remember, the magnification total is equal to the ocular lens times the objective lens. So I'll do a couple of these. A 15 times ocular and a 40 times objective lens. So what we're going to do to get the total magnification is we are going to multiply our ocular lens of 15 times magnification, times the 40 times magnification, and we get 600 times magnified. I'm going to do 3 as well. So a 15 times ocular lens and a 4 times objective lens. So 15 times 4 is 60 times magnified. So we just put an X, a big X between after. It's kind of like a unit of magnification. We say that it is 60 times larger. You could go ahead and practice these if you would like. This is a video on how to adjust and use a microscope. Because we aren't going to be able to use one, I think it's important just to be able to see how things would work so that when you do return to school and you're ready for Science 24, that you are prepared to use a microscope. Again, just in case, how to focus using a microscope is listed here. So we start with the lowest power. We place the microscope slide on the stage and fasten it with those stage clips. We look at the objective lens in the stage from the side and turn the focus knob so that the stage moves upward. Move it up as far as it'll go without letting the objective touch the cover slip or your specimen itself. We will look through the eyepiece and move the focus knob until it comes into focus. So we'll be moving the focus knob down because we know that it's already at the top. We're going to adjust the diaphragm or condenser, it can sometimes be called, and the light intensity for the greatest amount of light. And we'll move it around until we can see what we want. We use the fine focus knob to just really touch up that image itself. When we have something in focus, that's when you can rotate to the next power. So we can change to the medium. And what we can do is we may just need to readjust with that fine adjustment. Okay. We never want to start on a high or medium. We always start on low power. And the reason is the high power, because it's much longer, can actually touch the slide. And if we scratch it, that microscope needs some serious repair. When we're finished, we lower the stage all the way back down, put the cover on, call it a day.